Hello and welcome to Chapter 5, Loops and Iteration. As always, this lecture is copyright Creative Commons attribution, including the audio and the video and the slides and the book even. So now we're getting to our fourth basic pattern. We've talked about sequential, where steps happen one after another. We've talked about conditional, where steps may or may not happen. In Chapter 4, we talked about the store and retrieve pattern, and now we're going to talk about the looping pattern. And the looping pattern is the last of our really foundational ones, and it potentially is the most important one because it's the thing that allows us to get computers to do lots of things that, say, humans might get tired of, but computers don't tire of. And so after this, we'll start sort of becoming a little more skilled in the basic language capabilities. We'll talk about strings and then start talking about files and start doing some real work after we get done with this. So bear with us. It's going to be a while, but we'll get there. We'll get there. So, welcome to Repeated Steps. This is the example that I had in the first lecture, Chapter 1. And the basic idea, just to review, is that you have this while keyword. The while keyword sort of functions like an if in that it implicitly has a decision that it's going to make. And it's either going to do the code in the indented block or not do it, or skip it, basically. Right? So you either do it or you skip it. The difference between the while and the if is that it's going to do it many times as long as this question that we have remains true. Okay? And so in this case, n is 5, while n greater than 0, it functions like an if, so yes, it's going to run it. Prints out 5, subtracts 1, so it's 4. Goes back up, and ask the question again. Is n still greater than 0? Well, since it's 4, yes, we'll continue on. Out comes 4, then n gets subtracted. 3, 2, 3, 2. And then we come through, we print 1. We subtract n to 0. We go up, we go back up. N is now not greater than 0, so we come up and we execute outside the loop. We leave the loop, and that really means in the Python code we skip to whatever's lined up with the while statement, the same indent level as the while statement. And so that's how it works. And I just print n at the end here to remind ourselves that n ended up at 0, not at 1. The last thing we printed out in the loop, was the 1, but n ended up at 0 because this loop was going to run as long as n was greater than 0, so n had to sort of be not greater than 0 to get out of the loop. Okay? So that's basically a review of what we've done. Now, oh, wait, something else. Iteration variables. Okay, so the key to this is these loops can't run forever. We don't want them to run forever. We want them to run as long as we want them to run. They may run a very long time, but not forever. There's got to be a way to get out of them. Otherwise, we call them infinite loops, which we'll talk about in the next slide. And so the iteration variable is generally some variable that is changing each time through the loop, and we are changing it by subtracting 1 from it. And so this thing is going to keep running, and we can pretty much see that, oh, this is going to exit, right? Whatever n is, it could be a large number, but eventually it's going to get to 0, right? So the iteration variable controls how many times the loop runs, and it also allows us to do something different inside the loop. And of course, this is like a trivial loop where we're just printing the iteration variable, but it just means that this loop is going to run 5 times, and it's going to do something potentially different each time. If you just ran the loop that did the same thing over and over and over again with no data changing, that's kind of dull and pointless. So just because you have an iteration variable doesn't mean that you've properly constructed your loop. It's a common problem, or something we want to avoid, is an infinite loop. And here is a carefully constructed loop. We start n at 5 at the beginning. We have a good question at the end, while n greater than 0. It's going to run this as long as n is greater than 0. But the problem is we don't change in the little block. We don't change the n, which means it's going to come back and n is going to be 5. And then it's going to run this, and then it's going to be 5. And then it's going to run this, and it's going to be 5. And so this is an infinite loop, which means this loop will never exit. It will never get out. It's just going to run forever in here because n's not changing. Neither of these statements change n. So part of the iteration variable is there needs to be something that changes so that the loop will ultimately make progress to accomplish what it is and know when to stop. So this is an infinite loop. And of course, lather, rinse, repeat is commonly put on shampoo and conditioner, and so you can, next time you're in the shower, take a look at your shampoo and conditioner and find the infinite loop that's on most bottles of shampoo and conditioner. Now, here's another loop, just to emphasize that it's possible to structure these loops in a way that they never run. So this function is as an if. The while functions as an if. And so when n is set to 0 and we ask the question, it is literally going to make the decision based on n greater than 0. Well, it is not greater than 0, so it's going to go right by it. Over here, it's going to come in here and go right to there and never run these lines of code. And we call this a zero-trip loop. And that's okay. I mean, this is a silly one, of course. It just shows that the test, the question that's being asked, is above the lines that make up the body of the loop. And if it's false, the loop never runs. So it's possible that these loops have 0 trips. Okay? So that's a loop. Now, there are more than one way to sort of control the flow of a loop. The basic flow of the loop is when it gets to the bottom, it goes back up to the while and does the check. This is a different way of getting out of a loop or controlling the execution of a loop. There is a keyword or a part of the Python language called, what color did I got? Oh, green's over here, called break. If you looked back at reserved words, break was one of the reserved words. Break says, hey, if I'm in a loop, stop the loop, right? Get out of this loop. I'm done with this loop. And so here's this loop. Now the interesting thing we've done is I just got done talking to you about infinite loops. We have just constructed an infinite loop because the question is right there and the answer is yes, true, true. And that's a way to construct an infinite loop. We've done this because we have a different way of getting out of the loop. So we've constructed a loop that just on the face of it, just looking at that line, looks like an infinite loop. So what this loop does is it reads a line of input, checks to see if it's the string that we've entered is done, and if it is, we're going to skip out with his break and get out of the loop. Otherwise, we're going to print it. So at a high level, what this loop is going to do is prompt for strings of characters until we enter done. And that's exactly what it does. It prompts, we say hello there, it prints that out. We say finished, it prints that out. We say done, and it's done. So when we say done, it comes out and finishes the loop, and that's the end of the program. Okay, so to look at this in some more detail, the first time it comes in, does the raw input, because true is true, so it's going to run it, and then we enter hello there. It checks to see if what we'd entered is equal to the string done. It is not, so it skips, and it does the print. And we do this one more time, and we type finished, and then the line is not done. That's variable line does not have the value done in it. So we print that. We come in one more time, but this time this is true, and so it goes in and executes the break, and then it escapes the loop. And so you can think of, right, here is the body of this loop, because that's where the indentation starts and ends. The break says, break me out of the current loop that I'm in and get to that next line that has the same indent as the while. So whatever it is, break says we are done with this loop. When that statement executes, we are done with the loop. We're finished with the loop. It'll run until that executes because we've got this set to be while true. Okay, so there's a simpler, this is sort of a simple way to draw this. Break is sort of a jump to the statement immediately following the loop. If you really want to picture this, I think of this as kind of like a Star Trek transporter, where you kind of come into break and then your molecules are sent to the four corners of the universe and you reassemble outside of the loop. And so if we look at this sort of in my little roadmap version of these things, right, where while loop is going to run for a while, yada yada, there can actually be more than one break as long as they only get this. But the moment that somehow some if or whatever hits the break, then it gets out completely, and so it escapes the loop. And so it's sort of like you're zoom 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 zoom. You come in here, and then you are rematerialized outside the loop. That's what the break does. Okay, so break is one way to control the execution of loops. Now, Another way to control the execution of loops that doesn't actually exit the loop is called continue. Continue basically says, hey, I'm done with this iteration of the loop. Now, each time through the loop, as we call that an iteration. Continue says, I don't want to stop the loop, but I want to stop this iteration and advance to the next iteration. And so what we have here is we have the same basic loop, a while true, which kind of makes us an infinite loop. We're going to read a line, prompting with a less than sign. And if it's done, we're going to break. That code is down here, and we're going to print it if we fall through. So normally we'll be reading and printing, and if the line is done, we're going to break out. That's what we just got done doing. But the new part is right here. And this is, we'll learn this in the next chapter. If line sub 0, if the first character of the line is a pound sign, we're going to continue. And what continue says is it doesn't actually get us out of the loop. It jumps back up to the top of the loop, which means that it ignores, for that iteration, the rest of the loop, right? So if execution comes in here, let me clear that. If execution comes in here and hits this line, it goes back up to the while, okay? Which means whatever this is, it's not coming out of this if. It's going back up to the while, okay? So continue ends the current iteration and jumps to the top of the loop and starts the next iteration. And so if we look at how the code runs, hello there prints. Pound sign with first character doesn't print, so there is no printout right here. Print this is not done, and we enter done, and then the loop ends. Now another way to sort of draw this is the continue jumps to the top of the loop. It does run the question, right? It does check the question. And so here's another way to draw that picture. And so here again we have a loop, and it's happily running, and there can be breaks in there, and there could be continues in there. And as long as we don't hit a break or continue, the loop just sort of runs and goes up to the top. And at some point, some if, we hit the continue, and like a transporter, instead of going out of the loop, we go to the top of the loop. But it's important that we go and we check the question, right? So the continue is not likely to exit the loop unless the question has become false. So the continue is likely to come up here, run some more, then we hit the continue, it comes up here. Oops, I did that backwards. Run some more, clear this out. So the continue could run many times, right? So we have the loop runs a bunch of times, then finally we hit the continue goes up to the top. If it's still true, we'll run the loop some more, then you might hit the continue, then you might go up to the top, come down, round and round and round and round, hit the continue again, go up to the top, yada yada. Now in this particular loop, this break eventually is down here, and that's how we get out. Okay, so the continue goes back up to the top of the loop. So these loops that we construct with the while keyword are what we call indefinite loops. I mean, looking at the ones that we've written, which are 2 lines or 6 lines, we can kind of inspect them and understand when they're going to stop. And we're going to know that they're possible to stop them. A loop that won't stop is an infinite loop. Sometimes these loops can be rather complex, and you may not actually be able to look at them because there are many lines, and so we don't know. And so it's real careful. You have to be real careful when you construct these to make sure that they stop as things get more complicated. Now the cousin to indefinite loops are definite loops. And definite loops is something where we have a list of things or a set of things that are a kind of a known set of things, a finite set of things. And we're going to write a loop that's going to go through that set of things and do something to each thing in that set of things. And the keyword that we use for this is the for. So we use the Python for keyword that says we're going to write a loop, but instead of it just running until some condition becomes true or false or we hit a break, we're actually going to know how many times this is going to run. Now you can actually use break and continue in for loops. We call these definite loops because how long they're going to run is kind of well known, basically. So here's a simple definite loop. And it's kind of like that while loop that we just got done looking at, where it's counting down and then saying blast off. And so the way we construct this loop is we have the for keyword, which is part of the Python language, the in keyword, and then we have an iteration variable. I've chosen I as my iteration variable. And basically what we're saying is, dear Python, run this indented block, and there's only one line in the indented block. Run it once for each of the values in this little list. This is a Python list. Square brackets make Python lists, comma separated values. So it says, I would like I to be 5, then run this code. Then I would like I to be 4, then run this code. Then I would like I to be 3, then run this code. I should be 2, then run this code. And I should be 1, then run this code. And so this is a pretty clear, and I like this word in. It says, you know, doop, 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 and then run this each time. And so out of that comes 5, 4, 3, 2, 1, and then the loop is done. Python is doing all the tricky bits here. Python's figuring all these things out for us and handling all this, and then we're done. And so if you look at it, we have an iteration variable, but we didn't have to increment it. We didn't have to do anything. Python took care of a lot of things for us. And so when we're looping through known list of things, or later when we read a file, we're going to loop through the lines in the file. And so the for loop is a really nice, powerful, and it's syntactically cleaner. It's really quite nice. Now, it's important to realize that you don't have to just loop through numbers. I did that one with a set of descending numbers, so that it was equivalent to the while loop that I started at the beginning. But this is a loop where what it's going to loop through is a list. Close square brackets are a list in Python. This is a list of 3 strings, Joseph, Glenn, and Sally. They're string constants, and then commas are how we make lists. And so friends is a mnemonic variable. Python doesn't know anything about friends in particular, but I've chosen this variable name to be friends. And it's a list of 3 people, Joseph, Glenn, and Sally. And so I have an iteration variable called friend, and I'm going to loop through the set of friends. Now, Python doesn't know anything about singular. Python doesn't know anything about plural. I'm just choosing these variable names because it makes a lot of sense. This is a set of friends, because it has 3 of them in it, and this is a single friend. What it's really going to do is friend is going to take on the successive values, Joseph, Glenn, and Sally, and this little block of code is going to run once for each of those 3 items in the set, and the variable friend is going to take on the successive values of that set. So out of this comes 3 lines of printout. Happy New Year, Joseph. Happy New Year, Glenn. Happy New Year, Sally. Of course, this is the I bit right over here. But we just made it so, hey, Python, look, however many friends there are, run this code 1 time for each one. Change this variable friend to be each of the successive ones in order. And then we print that we're done. Okay. So the for loop, sort of, we go and try to make a picture of the for loop. The for loop is kind of a powerful thing. It does 2 things. It decides if we're done or not. How do we keep going in the loop? Or, well, I mean, and as long as we keep going, we're going to advance the I value, the iteration variable. It takes care of the responsibility of changing the iteration variable. We do not have to add lines of code in that change the iteration variable. Okay? And so if we take a look, you know, we come in, are we done? We're not done. Set I to the right thing, then print it. Out comes 5. Advance I, print it, advance it, print it, advance it, print it. Oh, now we're done, right? I was not the thing that decided when we were done. The for loop just keeps track internally as I moves through these things, and it goes like, oh, I'm all done. I'll take care of that. You finished. So it doesn't. There's no if in here. It's not like if I equals 1, stop. No. It just says you told me to do 5 things. I'm going to do 5 things, and then we're going to stop. And so again, the for loop here has got sort of 2 functions. Decides how long the loop's going to run and changes the iteration variable based on what you've told it to in this in clause. Okay? So I think in is a real elegant construct. It's just a keyword, but it's sort of, if you think about math, if you're familiar with sets, it's like something inside of a set of something. I think it's a real pretty way to think about it. And you can kind of think of it a little more abstractly, that you say, well, here's a little indented block of code, right? And I want it to run some number of times for each of the I values in the set 5, 4, 3, 2, 1. That's how I kind of think of it. So I think this is a real pretty syntax. Different languages have different looping syntax. I think this is really a very expressive, very pretty one. Yeah. So another way to so one way to think about this picture is that, you know, the for loop causes sort of repeated execution, and we're driving in the circle and then we stop, right? The other way to think about this is to think about it a little more abstractly, right? To say, You know, at the end of the day, all I'm really telling Python is I want to execute this block of code 5 times, and I want the variable I to change to these 3 values. So in a way, you could think of this as expanded as the for loop sets it to 5, then runs your code. The for loop then sets it to 4, runs your code. The for loop sets it to 3, runs your code. For loop sets it to 2, runs your code. Sets it to 1, runs your code. These 2 ways of looking at it are the same from your perspective, because you're just asking Python to do something. Whether it does it this way or whether it does it this way, you hardly can tell the difference. It's probably going to do it this way, but logically it's not that different. It's not different from doing it this way. You're saying, run this block of code, change I in the following way. Cool. It's like we don't have to worry. I mean, we can use mentally either model of what's going on inside, because it doesn't matter, because they're the same. Okay, so these definite loops are really cool. Starting in a couple of chapters, we'll mostly use definite loops to go through lists or dictionaries or tuples or files. And so it's a finite set of things. It can be a large set of things, but it's a finite set of things.